day, my viewers. You are welcome once again to another series of Alternative to Chemistry Practical. Today, we want to quickly consider another question. The question will display on the screen there. Read along with me. A is a solution of tetraoxosulfuric acid. Our A is a solution of tetraoxosulfuric acid. Then B contains 3.95 grams of what? B contains 3.95 grams of sodium triiocarbonate 4. So our B is sodium triiocarbonate 4 in 750 centimeter cube solution. So the question is saying that 3.95 grams dissolves in 750 cm cube. Remember, in our last episode, I told us that whenever a particular gram is not in 1000 centimeter cube, you are going to convert that mass to 1000 centimeter cube. And that's what we are going to do after I am done with the reading of the question. Okay? Then, if 22.70 cm cube of tetraoxosulfuric acid, note that that's our VA. Since it's alternative to practical, we have been given VA to be 22.70 cm cube of tetraoxosulfuric acid neutralized 25.0 cm cube of sodium carbonate. So our VB, that is the volume of base, is 25.0 cm cube. Now that's the question. Now that's the information we are provided with. So the people want to check out for the solution.
I will blow your mind.
Now from the question, we are asked to calculate the concentration of B in gram per dm cube. And remember, when you are calculating gram per dm cube, it means you are calculating mass concentration. And initially, they are giving us 3.95 gram of B dissolved in 750 cm cube. So from here now, we are going to calculate how many mass will dissolve in 1000. So if it is in 1000, how many mass? So let's represent it with S gram. And if we cross multiply, we are going to make S gram the subject of the formula. So, and that will be X is equal to, we multiply 3.95 by 1000 divided by 750. So what we are doing here is that they want to convert this mass in 750 cm cube to 1000 centimeter cube, which is also the same thing as gram per dm cube. So from here, we are going to have our S is equal to 5.27 gram per dm cube. Please make sure you use correct unit. If you put ordinary gram here, you are not going to have your correct mark in this place. And make sure you show this expression for you to get 1 mark here. So the next question asks us to calculate concentration of B in mole per dm cube. Take note that our B is sodium carbonate Ne2CO3. You remember that there are two formulas we can use to calculate molar concentration. We can use Savannah, or we can say molarity is equal to mass concentration over molar mass. And by the time you are using molarity is equal to mass concentration over molar mass, it means that you've already determined your mass concentration, which is in gram per dm cube, and you can also calculate your molar mass. Once you can able to get the two parameters, then molarity will work. So we can say molarity of B is equal to gram per dm cube, which is the same thing as mass concentration, over molar mass. Our molar mass is in gram per mole. Our molar mass is in gram per mole. So molarity of B, which is the same thing as conc of B in mole per dm cube, is equal to our mass concentration. We have done that earlier. Our mass concentration is 5.27 divided by. Now remember, you are going to calculate the molar mass of sodium carbonate. You must ensure that you show the calculation before you can get 1 mark. Don't just calculate it somewhere else and bring it here. If you calculate somewhere else and bring it here, you will not get the full mark that you're supposed to have for this calculation. So in that case, how many sodium atoms do we have here? We have 2, and that will be 2 multiplied by the atomic mass of sodium, which is 23 into bracket, plus atomic mass of carbon is 12, plus atomic mass of oxygen is 16, but we have 3 atoms of oxygen here multiplied by 3. So in that regard, we are going to have 5.27 divided by, if you do the calculations here, it's supposed to give us 106. So our molar concentration, which is mole per dm cube, is equal to, if you do your calculation very well, you are going to have 0.0497 mole per dm cube. Now remember, if you are calculating mole per dm cube, make sure that your final answer is a 3 significant figure. 3 significant figure if you are calculating your molarity. But you will observe that I have 0 before 4. If you have a 0 number before a real figure, that 0 you nullify it. It's not a figure yet, unless that 0 comes after a real figure like 1, like 2. If 0 comes before a real figure like 1, like 2, then that 0 is as weight, as meaning. But if 0 comes before any real figure, you are going to nullify that 0. So before you can get a full mark here, it must be in 3 significant figures, like the way I've done it right here. So you have your 1 mark here, and then you have your 2 marks here. The mark for calculation of the molar mass, and then the mark for correct substitution. Do you understand that? Now, the next question. Calculate the concentration of A in mole per dm cube. And remember, our A is what? What's our A? Our A is H2SO4. Our A is H2SO4, tetra oxosulfuric acid. And I said earlier, if you are calculating molarity, you can use 2 formulas. You can say mass conc over molar mass, or you can use Savannah, the other way around. But in this case now, we cannot use molarity is equal to mass conc over molar mass. And why? In this case, we were not given mass concentration of tetraoxosulfuric acid, so it will be too unknown if you have to use molarity is equal to mass conc over molar mass. So in that case, you are going to use this formula, which is CA over CB VB is equal to NA over NB. Ordinarily, writing this formula alone cannot fetch you any mark until you insert the right figure into the formula, and that fetch you a mark. Now here, before we can correctly fill this place, we will need chemical equations of the reaction. And what's the chemical equation of the reaction? We have tetraoxosulfuric H2SO4 combining with sodium carbonate Na2CO3 to give us sodium sulfate plus what? Plus water, and then plus CO2. If you check very well, is the equation balanced? How many hydrogen do we have? We have 2. We have 2. Sodium is 2 here, sodium is 2 here. So in that case, the equation is balanced. The mole ratio here is 1 and the mole ratio here is also 1. So let's quickly substitute the value. We have to calculate our Ca represents the molar concentration of A, which is unknown. Ca multiplied by our Va. I have highlighted that. Rewind the video to see it. I have highlighted our Va, whereby our Va is equal to 22.00 divided by our Cb. We have just calculated our Cb now, and our Cb is 0.0497 multiplied by our Bb, which is 25, is equal to our mole ratio 1:1. So you must ensure that you fill in, you substitute the formula correctly before you have mark here. So if you do this correctly, you are going to have 2 marks here. 1 mark for correct substitution and the other mark for mole ratio. So from there, we are going to make Ca the subject of the formula. And if you are making Ca the subject of the formula, if you are making Ca the subject of the formula, you are going to cross multiply. So here we are going to cross multiply to have Ca into bracket 22.70 multiplied by 1, which is equal to 0.0497 multiplied by 25 times 1. So here our Ca is equal to 0.0497 multiplied by 25 multiplied by 1 divided by 22.70 multiplied by 1. Our final answer Ca, our final answer is equal to 0.0547 mole per dm cube. Remember that this must be in 3 significant figure. This must be in 3 significant figure, and then you must ensure that you put correct unit before you can have full mark for this. And then making Ca the subject of the formula will hand you 1 mark here, another 1 mark here, your final answer. Then you have your 2 marks. And most of the time, you always have 4 marks whenever you are using this formula. I hope you understand that. Now let's check the next question. Now, if you are calculating A in gram per kg, remember you can still make use of molarity is equal to mass concentration over molar mass, and that means that we are using molarity of A. We can now say our Ca is equal to gram per dm cube, which is the mass concentration, over molar mass. The unit of molar mass is in gram per mole. And recall that we have calculated our molarity of A. This one will also be gram per dm cube of A and gram per mole of A. Do you understand now? So we are going to make use of our previous figure, which is 0.0547 is equal to, now we have to calculate gram per dm. So this is the one we are looking for, divided by the molar mass. And remember, we are going to calculate molar mass of tetraoxosulfate 6 acid. In that regard, we are going to see how many atoms of hydrogen we have. We have 2. 1 multiplied by 2 plus our sulfur, it is 32, plus our oxygen, 3, multiplied by 4. Okay, so 0.0547 is equal to gram per dm cube. If we do the calculation here very well, supposed to have 98. So our gram per dm cube now, gram multiplied by 98, which is equal to 5.36 gram per dm cube. 5.36 gram per dm cube. That's the mass concentration of A. Alright. Now the question asks us to calculate the number of hydrozonium ion. Remember, when you are calculating hydrozonium ion, it's the same thing as saying you are calculating number of hydrogen ion, and then you can only get that from acid, okay, which could be obtained from the result in question A, I. Do you get that now? So before we can actually calculate the number of hydrozonium ion, remember I told us that that should be tetrahydrosis acid. That's where we can get hydrozonium ion. Before you can actually get correct mark for this question, you need to do the dissociation of this acid, which is tetrahydrosis, and it will give you 2 hydrogen ion plus SO4 2 minus. You know, it will be in aqueous solution, and this one is also aqueous. So when you dissociate like this, you are going to have 2 number of hydrogen ion. But remember that these 2 number of hydrogen ion represent the mole per dm cube of A we calculate the other time. So in order to calculate the number of hydrogen ion, we'll be having these two multiplied by our concentration. What was our concentration? I want to get our molar concentration was 0.0547. Then recall that when you are calculating our number of ion, we have mole is equal to number of ion all over Avogadro's constant, which is 6.02 multiplied by 10 raised to the power 23. So here we'll be having, we make our number of mole the subject of the formula. So our mole is this now. Our mole is this, and then we'll be having number of hydrogen ion is equal to, so we substitute mole into this formula to have 2 multiplied by 0.0547 multiplied by 6, this figure 6.02 multiplied by. So what's our final answer? Remember, what are we calculating? We want to calculate number of hydrozonium ion, and the equation, the formula that relates number of hydrozonium ion is this formula. Mole is equal to number of ion divided by Avogadro's constant. Okay? Then our final answer will be 6.59 multiplied by 10 raised to the power 24 ion. That's our final answer. That's the number of hydrogen ion. That's the number of what? That's the number of hydrogen ion. Let me check our final question. The question says, suggest the possible indicator for the reaction. Remember that the reaction is between a strong acid and a weak base. We only have 3 strong acids: H2SO4, tetrahydrosis acid, triazole-95 acid, and hydrochloric acid. Those are the 3 strong acids that we have. Then versus sodium carbonate. Sodium carbonate is one of the weak base. So because of that, we'll be using methyl orange. So for this kind of reaction, a strong acid versus a weak base, we'll be using methyl orange. And the reason is that we are using strong acid. So if you have not subscribed, kindly subscribe.